So, hello everyone. This is the Leetcode daily challenge problem. Find the smallest letter greater than target. So, if the input is here, the input is an array and the target element is A, right? So, your task is to find the lexicographically greater element. As input is C, F, J. So, what are the lexicographically greater elements than the target element? So C is greater, F is greater, J is greater. But what is lexicographically? If we take an example, X, Y, Z. If this is an array and the target element should be P. So greater element are X, Y, Z. Both all are greater, but lexicographically greater is X. And here one condition is given that whichever the array is given, A, B, C, this is sorted, right? This is sorted in order. So this is very easy problem. If you have tried by yourself, then it is good. If you haven't, then please take a look. Otherwise, let's move to the solution. So the first solution will be brute force. Like in brute force, what we can do? Simply traverse the whole array. If we will traverse the whole that letters array, right? If we are traversing this array, and if this element is greater than that target element, simply return that, right? Otherwise, in that question there is a condition that if no element is found, then return letters of 0, right? So this can be the pseudo code. But in this approach, we are using order of n time complexity and order of 1 space complexity. Why? Because this whole array is traversing once. So time complexity will be order of n and space complexity will be order of 1. What if I will try to optimize this solution? Yes, there is a way. So for that we can use binary search. How we will use binary search? Let's take an example. A, E, I, M, Q, U. Right. If we will take this example and suppose target element is P. So as you see, this element is this array is in sorted order. So for binary search, we will take a left here and right here, right? So left will be 0 and right will be like n minus 1 we can say, and n will be the size of this array. So 0 and 0, 1, 2, 3, 4 and 5. So if we will find the mid element, left plus right minus 2, left plus right by 2, so 5 by 2 it will be 2, right? So here check if this letters of mid is less than or equal to target. Yes, this is what हम लोग करते हैं binary search में, right? This is the approach we use in binary search. Letters of mid, if it is less than equal to target, then simply move left to mid plus 1. So left will be here 3. Else if यानी कि there is no letters of mid is not less than equal to target, if it is greater, then we will move right ka mid plus 1. Okay, so right we will move here, but in this condition here letters of I is less than or equal to target, so we will move just left ka mid plus 1. So these will be two conditions, and after that if left, it means left is moving mid plus 1, then mid plus 1, then mid plus 1. So if left is equal to n, if left is equal to array का size, then return letters of 0, because there is no element which is found lexicographically greater than the target element. So letters का 0. Otherwise, simply return that left, because left will be our answer, right? So this is the approach which we can use here. If we are going to talk about time complexity and space complexity, so time complexity will be order of log n, because every time we are just halving the array, like half, then half. So we are doing the half array every time. So it will be order of log n. And if we will talk about space complexity, it will be order of 1, because no extra space is going to be used. So this is the better approach than the previous one, right? You can optimize it further also. If you have any other solution, do comment it below. I will see your approach. So thank you so much for watching. Have a good day.